welcome to this tutorial on normalizing binary numbers. And if you watched my previous tutorial videos, you'll have seen how to convert between floating point, binary and decimal. And what I'm now going to do is show you how to normalize an unnormalized binary number, because in those videos we just dealt with floating point numbers which were already normalized. So the first step is to normalize the mantissa, and a normalized mantissa is going to have a different number either side of the binary point. It's going to be 0.1 for a positive number and 1.0 for a negative number. My number here is a positive number, so to normalize this I've just got to move the binary point one space to the right. I'm going to write that out again as a normalized mantissa. And the second part is to, we've got to record the number of moves to normalize our mantissa, and for this one it was just one move to the right. And we've now got to compensate for what we did here, because if we just wrote out our floating point number as with this mantissa and this exponent, then it would be a different number to what our floating point number is here. So we've got to compensate for the change that we made here by changing the exponent. And if we calculate the value of what the exponent is at the moment in denary, it is minus 32 because it's a negative value, plus 16, plus 8, plus 4, plus 2, plus 1 equals minus 1. So that's our original exponent. We've now moved this binary point one space to the right, and we've got to apply this formula here. Original exponent minus moves to normalize the mantissa is going to give us our new exponent. So essentially we've got to do minus 1 and then minus 1 because this is one move here. So minus 1, and that's going to give us a new exponent of minus 2. And if we write that exponent out in binary, that's the new exponent we're going to have. And we can then write out our normalized mantissa over here, and that will be our final answer. Like that, making sure to preserve the same number of bits in the number. Okay, so in our final binary floating point number then here, this is our normalized version of this number. That's my mantissa and that's my exponent. I'm now going to move on to another example of normalizing a floating point number. Okay, so this is my next question, and it's asking me to normalize this new floating point number. And this number is going to be a negative number, because if we normalize it, then I can see that I'm going to have a 1 on the left hand side and a 0 on the right hand side. And that's our first step to normalize the mantissa. So we move this over here, counting the number of steps that we take: 1, 2, 3, 4, 5, 6. We can see for our stage 2 that this is going to be 6 steps to normalize the mantissa. So our normalized mantissa then is going to look something like this. Okay, and we're going to calculate our new exponent now using our formula that we've got down here. So the original exponent here is 3. That converts that exponent from binary to denary. And the number of moves that we took was 6. So do 3 minus 6, and our new exponent is minus 3. So in binary, that's going to be a new exponent of this number just here, because minus 32 plus 16 plus 8 plus 4 plus 1 equals minus 3. So we can now write out our new floating point number that's been normalised. My exponent down here is going to be 1111101. And my new mantissa then from here, I've got to remember to preserve the same number of bits. So I'm going to pad with zeros on the end here. And that's my final floating point number there, which has been normalised, with that being the mantissa and that being the exponent. Okay, I hope you found this tutorial video on normalising binary numbers useful. Thanks for watching.